In this video, we're going to take a look at an alternative method for constructing a confidence interval called the Walt confidence interval. And so in the previous video, we walked through what's called the scored confidence interval for a proportion. And that was a really horrible looking formula. So that is going to give us actually the most accurate estimate. But the downside is it's a really awful looking calculation. Again, you don't ever want to do that by hand, but you certainly, if you're sitting in front of a computer and you have R in front of you, that would be the best way to do it. If you're not sitting in front of a computer or you don't have R and you want to do a quick calculation by hand to come up with a good estimate for a confidence interval, then a Walt confidence interval is a good option, because here you can see that the formulas to find these cutoffs, so this would be like the lower cutoff over here, and this would be the upper cutoff over here. These are not too bad. They really just depend on three things: p hat, z alpha over 2, and the sample size. So for our example, if we continue to use the did you wear a face covering over the previous week example, then we had a sample size n, which was 443. We had a sample proportion p hat, which is 0.55. And for a 95% confidence interval, our z alpha over 2 is 1.96. And so if we plug these three values in, so every time I see a p hat, I'm going to plug in 0.55. Every time I see n, I replace that with 443. And when I see z alpha over 2, I plug in 1.96. So I'm going to skip the calculation there. But what you can see, what you can check is if we were to plug these three values in to the lower cutoff, we're going to get a lower cutoff L, which is 0.504. That gives me my lower bound for my confidence interval for the proportion, and then the upper limit when we calculate that is 0.596. And if we compare this to the scored confidence interval that we found on the previous page, that was between 0.503 and 0.598. Okay, so we're pretty much in the same ballpark. We haven't lost too much by simplifying these calculations. So the advantage to the Walt confidence interval is that we can do it by hand. It's not too difficult to calculate them by hand. The downside is this method is less accurate, and the reason why is if you kind of look at this formula, it makes sense that basically all we're doing is we're approximating the standard error for the sampling distribution, which really should have p's over here, by using the plug-in principle. Basically, we don't know what p is, so we're going to approximate the standard error by using our best estimate for p, which was the proportion from our sample. And so when, just like with the case of a mean, when we didn't know what sigma was and instead we used the standard deviation from the sample, that created a little bit of issue with accuracy, and our distribution actually was not normal, but we had to use a t-distribution. And so we have a similar issue here, and that is when I substitute my p hat in place of p to estimate the standard error, then we lose quite a bit of accuracy. And so we should be a little bit wary of this estimate over here. But for this particular case, it worked out pretty nicely. When your sample proportion is pretty close to 0.5, this is the Walt confidence interval is going to do a pretty good job. But let me just say that if the population proportion p is something that's actually closer to 0 or something that's closer to 1, then the bit of accuracy that we lose from the Walt estimate over here is going to be magnified in those cases. But comparing the two, we don't see much of a difference in this case because our sample proportion was something that was close to 1/2.